Hello everyone, and welcome to Jam Academy. In this problem, we have a ball of mass m attached to a string of length L. Now, the ball moves around in a horizontal circle. We are required to calculate the tension in the string. So let's see what happens. We have to start this problem by doing a free body diagram. So the weight of the ball is downwards, vertically downwards. There is tension in the string acting along the string upwards. This angle is theta. The angles under the arms of letter Z are equal. So if we look at it carefully, we can resolve the tension in the string into two components. You have here, this will be T cosine theta, and this will be T sine theta. Now, this brings us to 2 points. One, we need to apply Newton's second law along the y direction and along the x direction. So if we do the summation of Fy, this will be equal to T cosine theta minus mg. All of that should be equal to 0. This means that T cosine theta is equal to mg. In other words, T is equal to mg divided by the cosine of theta. That gives us the expression for T. Now, if we sum the forces along the radial direction, this is equal to ma radial. Now, one of the things when you are given a problem like this, the question that should occur in your mind is what provides the centripetal force that causes the bulb to move around in a horizontal circle. In this particular case, it is not strictly the tension, but the component of the tension directed towards the center. So we now have here T sine theta equal to MAR. This would mean that, let's call this equation 1. What do we know? T is mg divided by cosine theta, and we are multiplying that with sine theta, all of this equal to MAR. Hence, mg, the tangent of theta, y, because sine over cosine is tangent, this is equal to MAR. The m's can go away, and the centripetal acceleration is given by g, the tangent of theta. This gives us the centripetal acceleration of the ball. Hence, we can now calculate the numerical value of T. This is going to be equal to 2 kilograms multiplied by, I'm going to take G as 10 meters per square seconds, just to simplify and divided by cosine of 30. I believe cosine of 30 is root 3 over 2. So this will be equal to 20 root 3 over 2, which is just going to be equal to 10 root 3 newtons. That gives us the tension in the string, which is what was required of you. Thank you so much for your time. I look forward to the next lesson. Remain blessed, and bye-bye.